Once we have established that we're up and running, we then are mostly concerned with actually running spectra, capturing spectra. That is what this system is all about. As with all systems, the first items are going to be that the device wants to know that it has been still in calibration. So one of the first things that you will be prompted to do, even if you were to attempt to run a sample spectra, is you'll be told that you have to run gain stabilization and source check before you're able to go. And this is a precaution to make sure that the device is operating as it should, as designed. Now the process itself can be pulled up from any of these menus. We can do auto gain stabilization, and the first thing that it will look for is to make sure that we are using a known substance with a known energy and a known weight. This is potassium chloride filled in here. Of course, with any potassium chloride, there's always going to be a certain population of potassium-40, which is a naturally occurring radioactive material. It has a very characteristic energy at 1461 keV, kiloelectron volts. We know what the activity of this is. It's recorded on the label. We know the weight, and we know the date. And we put this into the lead chamber and allow the detector to make sure that it starts reading energy lines and peaks.
So the red line is our centroid for the potassium-40, and you see slowly the peak is growing right there on the red line. That lets us know visually that the unit is in calibration, but it will perform its own diagnostic and confirm back to us that it is acceptable in terms of calibration. The K40 sample, which is in the Marinelli beaker, is included in the FoodSafe kit as well. So this is prepared very, very nicely for you. You don't have to develop your own calibration sample.
We are going to shorten this because, of course, this is a introduction session. By default, this is going to run about half an hour. Now, it seems like a long time, but you don't want to take chances when you're trying to work with very low levels of activity, potentially that will be in food or soil samples. Presently, for instance, in Japan, where there's a concern of radioactive levels in soil and in food, anything that would be fed to children is rated cannot exceed 50 becquerel per gram. These are very, very low amounts of activity, and that is why you need to collect as much information as possible. This is all about statistical probability, and the more information you can have, the better your statistical confidence will be. Now, we are going to shorten this because, of course, this is a introduction session. After you have stabilized and double-checked your source, the most important thing that you're always going to want to do when you're doing food samples and comparisons, comparing against what? Well, we want to compare against what our background radiation is, so we can identify that and subtract that out of the picture, and then know that all that's left is the activity that we've introduced in the meantime. We would continue, most likely in the field, to be using these Marinelli type beakers. And it's very important that you always perform your samples and activities with the same type of geometry, same type of shape, same type of positioning. So we still will use an empty Marinelli chamber. Put that inside of the lead, put the detector in, and from our file we will acquire a background. It is always a good idea to know what you're dealing with in terms of weight. The results people will be looking for is in becquerel per gram, and so as such we want to know how much material we are dealing with. The Marinelli chambers generally are going to be 109, 110 grams, and we can store this information as what's called a tear. And for 60 seconds, the scintillator inside will be collecting however much gamma activity, gamma photons are active here in this room at this time. A background spectrum has been loaded and therefore will be used as our reference from this point moving forward here. For our sample, we will be using a point source of cesium-137. Cesium-137 is a common byproduct of plutonium reaction. And again, we're now going to be comparing against what we measured when there was nothing in the device, except for the detector. The user will be prompted to provide some information. We can't just jump right into it. We will be asked right at the beginning for our sample data, how much acquisition time do we wish to use? What type of matrix will we be using? Will it be soil or water or a filter?
So we store all the pertinent information about each sample as one file in the unit. Each collection process is stored, and each unit has its own weight, its own sample collection time, any notes, a name of a location, all appended to that one measurement.
That is absolutely correct.
Yeah.
At the end of the spectrum report, we will have a good deal of information useful for the customer. Again, the feature that is most important on this report is that there will be a summary of isotopes that were found in that sample. In this case, it is telling us that cesium-137 was located. It will tell us activity specific to the entire sample amount. And furthermore, over onto the far right, final column of the report, it's very important. It will announce the becquerel per gram. So it's going to tell us the information that the food sample person, the soil sampler, any kind of the radiation authority mostly wants to know that bottom line. What's the becquerel per gram? And the food safe does that for you.